Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day in my virtual classroom. You know, I was just thinking of right now is every time I start a recording, it's well, hello and welcome YouTube, whatever. You know, a lot of times when my students end up watching a video in my class, like they have independent time to start and whatever, and they don't have a chance to either put in their headphones or turn down their volume yet, that a lot of times they pop up a video and they got to pause it quickly or do something, but it's too late. It got, well, hello and welcome YouTube. And that happens. All right, guys. Here I'm going to be reviewing a practice quiz, if you will. Everything on the volumes of the solids that we've been covering in this last little series of videos here. We've been looking at volumes of prisms and cylinders and pyramids and cones and spheres. Okay, so all of those together, we are going to take the volume of each of them in certain ways. We've had composite figures and oblique figures. I don't think this is any oblique figures on the practice quiz thing that I have here, but you know, anything can happen based on what's there. Just make sure you're aware of it. I'll show you what this thing looks like here, and if you want to get one PDF of this for yourself, you can check down in the description section below and download it for yourself down there. It's one that I created. The first 6 problems here that we're going to do, we're just going to name these figures as they're kind of just as they're shown, and then we have 1, 2, 3, 4, 5, 6 problems to find volumes for, and then 7 and 8, or 13, 14, but the last 2 are composite figures right here for which we'll calculate. You want a calculator for these ones. The last 2 we're going to round to the nearest hundredth. The other ones we'll leave in terms of pi if it's got a circular kind of basis to it, whether it's cylindrical or spherical, or conical, I guess, for cones. And yeah, we'll just kind of mosey on from there. Now, before we do that, let me just go ahead and write out some of the formulas and the ideas for you that we are playing with here. Let me just open up a new page for this. Give me a moment. Okay, so for all these here, here's what we're doing. We got volumes of cylinders and prisms. So volume of prism equals volume of cylinder, which is area of base times height. Now, you have different bases that we play with. In a cylinder, it's always a circle. So the area of a circular base is going to be pi r squared. But we've been looking also at areas of bases of rectangles, which is length times width, and area of base of triangle, which is 1/2 base times height. Honestly, that's mostly all we've been looking at. We haven't been doing areas of trapezoids or areas of pentagons or anything like that, at least not where you have to come up with it on your own. So those are really the big 3 that we're looking at for area of base width. You could say area of square, but that's also still a length times width kind of idea, you know, even if it's a square thing. So that's volume of prism, volume of cylinder. We also are doing volume of pyramid, which is going to be the same as volume of cone, which is 1/3 the area of base times height. Now, the height that we're referencing here, guys, is always the altitudinal height, the one that goes straight up into your apex or your other base, perpendicular to the bottom base, or the the other base that's being identified, if you will. So those are the 2 formulas that we're playing with there, and then we have the volume of the sphere, which is kind of in its own little world here. It's 4/3 pi r cubed, like that. R is the radius of the sphere that you're talking about. Sometimes we're given a diameter, and then we got to find it. So that kind of thing happens. So that's their basic breakdown. I'm going to be using those ones. I often label area of base. I identify the area of base and height before I multiply them together, and I'll show you some calculator work. So let's go ahead and get to work right now, guys. Before we actually do those formulas, let's look at some of these things and let's name them. Number 1 is indeed a cylinder. Cylinders, guys, they are the equivalent of a circular prism. In terms of they have 2 congruent bases where they meet up from this kind of rectangular nature lateral face right here. We're going to have to talk about more about lateral faces when we do surface area, which is after this region. But cylinders are like circular prisms. Now, this is also a prism, and prisms are named based on their bases. Circular prism, but we call it a cylinder. This is a triangular prism. It's not a pyramid. Pyramids do something like number 3. This is a triangular prism right there. Number 3 is a pyramid because it has a singular base, and then all edges from the corners of that base meet up to the apex right here, but it is also named based off its base. This base happens to be a rectangle. all right angles and opposite sides congruent, but not all sides congruent. This is a rectangular pyramid. Pyramid. Number 4 is a cone. It's basically like a circular pyramid as it has a circle base, like that. And, in that way, it's just a cone. Number 5 is a sphere. And number 6 appears to be a pyramid as well, but remember, we name it based on its base. Maybe a challenge for my students because we're not really doing volumes of these ones too much, but it still has a name. I want you to know the names of your shapes. This is 1, 2, 3, 4, 5, 6-sided shape. That is a hexagon. So this is a hexagonal pyramid. If you didn't actually know how to say that or how to write it, if you called it a hexagon pyramid, I wouldn't be too upset by that. I'm just trying to see that you know that it's based off the name of the base itself. And I'm not expecting that you know a 9-sided shape is a nonagon and, a dodecagon is a 12-sided shape. I'll make sure if I give you something a little tricky like that. There's certain things you could say, right? Okay, guys. Let's keep moving forward here. Let's start to do the calculations. Here are the nuts and bolts, the nitty-gritty of all this. Now, it's important to know the names because understanding, once again, you need to know the base and how to take its area. So this one right here, guys, it appears that we do have, in the volume of this figure, leave your answer in terms of pi if necessary. We won't have to here. We have a rectangular prism. Well, actually, it depends on how you look at this. If this is your base down here, great drawing. Nice job, Mr. Robinson. If this is your base down here, then it's a rectangular prism because this 11 means this is 11, so that's a rectangle. But you could call this a square prism if you identify this as your base, and then it's a 6 by 6. You know what I mean? And 6 by 6 by 11, so it's a square prism. But it doesn't really matter. The whole point of it, choose something as a base that'll be the area of the base, and then the other thing will be the height. For the sake of argument, guys, let's go with the square prism idea. Let's call this the base, the 6 by 6 here. It's going to be a square prism. Got a 6 by 6 right here. So the area of the base is 6 times 6, which is 36 square feet. And now my height, you have to remember that height is in reference to the distance, the perpendicular distance between your bases. So the height in this case, if this is a base and this is a base, your height is this one right here. It's the 11. So my height is 11 feet. Now, if you chose the 6 by 11 as your rectangular base, then 6 would be your height. Either way, you're going to multiply all three values together here. But the total volume is going to be area of base times height. So we're going to take 36, we're going to multiply it with the 11, and we get 396 cubic feet. And we're done. Leave units in your answer every single time. If you don't leave them here, I ain't mad, but you'll see me do it every time as you have seen it. By the way, as I'm mentioning all these things and I revisited the volumes and stuff like that, if you haven't seen my other videos and you don't understand what I'm saying by any of this, I should have said this a long time ago, please, please, please go back to some of those because that's where I'd say a lot more like introductory stuff. But I'll point to some of it here as well as needed. Okay, guys. Number 8. Number 8 is a cone. And in a cone, the volume is 1/3 the area of the base times the height. Now, the base is a circle. So the area of that circle there is pi r squared, and that means we need the radius. This 2, as it's pointed in the middle, and it kind of shows a whole dotted line across there, I think we can play under the assumption that 2 is the diameter, not the radius. So the radius is going to be half of 2. 2 divided by 2, which is 1. The radius is 1 foot. 1 foot radius, the area of the base is going to be pi times that radius squared. 1 squared is not 2, it's 1. And 1 times pi is pi. So the area of your base is pi square feet. That looks weird, even to me it does. It sounds weird, but that's what it is. That's the area of the base. And your height, the distance from, the altitudinal distance, as you can see here, from the circular base to the apex of the cone is 5 feet. So we have area of base times height, and we're going to leave our answer in terms of pi, or 1/3. 1/3 area of base times height. We're going to leave our answer in terms of pi. Volume is 1/3 area of base times height, and that gives us 1 times pi times 5 is 5 pi, and that's divided by 3. So 5 pi over 3 cubic feet. That's your final answer. And yes, that is your final answer. I am not going to take 5 over 3 and round it, because when I say leave your answer in terms of pi, I'm saying give me an exact answer. 5 over 3 is 1.6 repeating. You cut that off at 1.67 or 1.7 and multiply that with pi, you have become what's the word? You've become imprecise. You've become imprecise. This is exact. We're going to leave it like that. It's done. There's nothing else to it. We're finished. All right. That is number 8 in terms of pi. All right, number 9, we have a triangular prism. Nice little block of cheese right here. We have to find the area, or excuse me, the area of the triangle, and then do the volume by area of base times height. Now, the area of either of these triangles here, let's see these labels here. It looks like 4 is going to be our height, and yes, 4 does need height of prism. And yes, 4 needs to be the height because these aren't all rectangles all around here. There are 2 triangles. Those are the bases. The height is the distance in between. That's the 4. Now, the triangle here, either one of these, you see a 6 labeled here. That means a 6 is going to be labeled here because your bases will be congruent. So you have a right triangle. Let me break this down. You have a right triangle here with 6 meters here, 8 meters here, and 10 meters here. Now, the area of a triangle is 1/2 base times height. Not the prism height, but the triangle height. A triangle's height is always perpendicular to its base that you identify. So a base has to be one of these 3 lengths right here. It actually can't be the 10 because I don't know the perpendicular distance right here. If I knew it, I could do it, but I don't. Therefore, we can't use the 10. The 10 is actually just a decoy. We shouldn't be using the 10 for anything in this problem. We're going to be using either the 6 or the 8 as the base, and then the other one is the height. If 6 is the base, 8 is the height because 8 is perpendicular with 6. And if 8 is the base, then 6 is the height. Either way, I'll call 8 the base, 6 the height. Let's do area of base is 1/2 base length of, this is weird, base is base of the prism. This base here is the base of the base of the triangle. 1/2 base times height. Half of 8 is 4. 4 times 6 is 24. So the area of base is 24 square meters. There we go. So 24 square meters for area of base, height is 4. The volume of your triangular prism is going to be area of base times height. I think that's 96, 24, 40, yeah, 96. So that volume is going to be 96 cubic meters. Beautiful. Any questions? Leave in the comments. All right, number 10. Number 10, we have a sphere. One second. Number 10, we have a sphere. It's a 7-mile radius of this sphere. It's like an explosion, that 7-mile radius explosion. Let's find the volume of the sphere. Volume is 4/3 pi r cubed. R is the radius. We see the radius right here of 7 miles. Let's go straight into it. Volume is 4/3 pi times the radius cubed. 7 cubed is 343. And we have to do 343 times 4 divided by 3 times pi. Now remember, these are leaving our answers in terms of pi, which means no rounding at its current juncture. So I have to actually do 4 times 343. That one I don't know off the top of my head. I don't want to guess and make a mistake. So I'm going to go to the calculator here, and I'm going to do 343 times 4, because those are both in the numerator, and I get 1372. Now, does 1372 divide by 3? Apparently it does not. So I'm going to leave the 1372 on this. It's going to be multiplied by pi and divided by 3. We've mentioned that before. If we're leaving in terms of pi, that means I want an exact answer. And if a fraction happens to be part of the exact answer, so be it. That's completely acceptable. If I ask you to round to the nearest tenth at some point, hey, we can do that as well. Just type it all in the calculator. But leave in terms of pi means, guys, I didn't multiply the pi in my calculation either. I went ahead and there we go. I went ahead and I left it out so I could write it here. So 1372 pi over 3 cubic miles. If you'd love to know that approximation, I'll gladly tell you right now. Let me multiply that by pi. That whole answer, guys, is approximately 1,436 cubic miles. There you go. If you ever wanted to round to the nearest, 1,437 if you round to the nearest whole number. All right, 2 more where we do in terms of pi here with regular figures, and then we'll go to some composites on 13 and 14. Number 11, I have a cylinder, which again, it's a massive cylinder, 20 kilometer diameter, and we're going to have to get a radius because area of base is pi r squared. So in the cylinder here, area of base being pi r squared, let me do radius first, 20 over 2, which is 10 kilometers. So area of base is pi times the radius squared. That's going to be 100 pi square kilometers. Okay. Now, I've made mention of this before. Even if you were to round to the nearest tenth for the final volume, you do not round early, meaning I'm not done with my answer yet. This still has to multiply by 8. So I wouldn't want to multiply this by pi, get some number, round it, and then multiply by 8 and round again. So leave the 100 pi for now, even if you have to round to the nearest tenth, and then go from there. The height is 8 kilometers. Your volume of any prism, including circular prisms like cylinders, is area of base times height. So it's 100 pi times 8, and that's 800 pi cubic kilometers, like that. That's your final answer in terms of pi. We're done. Okay. All right, number 12, we have a square pyramid. It's a 5 by 5 on bottom. Literally, that's area of base, 5 by 5, and then a 6-meter height. So volume of the pyramid here is using area of base times height. The area of the base is 5 times 5, or 5 squared. That's going to give us 25 square meters. Our height, our altitudinal height there is 6 meters. So the volume here is going to be 1/3 area of base times height. We can't take 1/3 of 25, but we can take 1/3 of 6. 6 divided by 3 is 2, and 2 times 25 is 50. So we're going to get 50 cubic meters right there. And that one's actually kind of one of the easier problems outside of the 1/3, taking that into account. All right, so those are those problems, guys. I have 2 more problems left involving kind of all of our shapes except for a sphere here. But what we're going to do, we're going to take the volumes of these 2 things separately and then add them together. Take the volumes of these 2 things separately and then subtract the cone from the pyramid. So we'll go in that fashion. Let's take a look at what we got here. You've seen me label these before. I'll call the pyramid figure 1 and the rectangular prism figure 2. Now, if you notice here, they share the same rectangular base of a 10 by 4 rectangle right there. So this is also going to be 10 by 4, just so you're aware. So to find the volume of each of these, let's first find the area of the base of really both of them. The area of the base of either one is that 10 by 4, which is 40 square feet. 40 square feet. I'm going to apply that to both of them when I do area of base times height, or 1/3 or whatever. Now, the height of object 1, the pyramid, is 4 feet tall right there. And then the height of object 2, this rectangular prism, is 3 feet right there. When I find the volume of object 1 right here, the pyramid, that's going to be 1/3 area of base times height. So area of base is 40, height is 4. By the way, these answers are going to be rounded to the nearest hundredth. That's 2 decimal places. I'm not going to round till the very end, though. So 1/3 of 40 times 4 here, that's going to give me 40 times 4 is 160. That's going to give me 160 thirds cubic feet right there. Now, I'm not done with the answer, as I'm going to add one with the other. And I don't yet want to round because I'm not done. I'm still going to be adding it with something over here. All right, now the volume of the second guy here is just area of base times height. That's just 40 times this 3 right here. And that's going to be 120 cubic feet, like that. The volume of the total thing is going to be volume 1 plus volume 2. So we're going to be adding 160 thirds with 120. Now, I'm not asking you, again, to get an exact answer. In this case, I am asking you to round to the nearest hundredth. This is where we use the calculator, and we allow the rounding after we compute it through the calculator. So let's go to the calculator here. I'm wrapping up pretty fast here. I think I'll get done by the 25-minute mark. Let's do 160 thirds. Let me clear this. 160 thirds plus 120 there. And we're going to be getting about 173.33. That's the nearest hundredth, 2 decimal places. I'm going to write that. 173.33 cubic feet. That's your rounding. All right. It was necessary. It was absolutely necessary. And that is the volume of that object, of that house, all right, of the temple. All right, here we have another pyramid and with a cone in the middle. The pyramid I'll call figure 1. We'll subtract the cone after that, figure 2. Remember, the cone is the hollow part that we're kind of removing from the object. Let's see what we can play with here. I have a 9, so, okay, it's a square pyramid. I have a 9 by 9 square pyramid. It's inverted, it's upside down. You see that height of 8. The height actually is for both the pyramid and the cone, as they both meet at the same apex over here. So the volume of the pyramid comes from 1/3 area of base times height. Well, actually, both of them are 1/3 area of base times height. But the area of the base of the pyramid is by doing a 9 by 9 or 9 squared, because it is a square. That's 81 square meters. Now the height of both of these, remember, is 8 meters. So when I do the volume of the pyramid, that's going to be 1/3 area of the base times height. You can take 1/3 of 81. That's 27. I don't know 27 times 8 though. Let me get it for you. 270 minus 54 is 216. 216. What was this? Cubic meters. So that's the volume of the pyramid. Now let's take the volume of the cone and then we'll subtract all that out. So the area of the cone comes from this 6 meters, again, appears to be a diameter. Once they draw a red line like that, they're kind of pointing to the fact it's the whole thing. So 6 meter diameter means a 3, I don't want to put a meters there, means a 3 meter radius. Okay, 3 meter radius. So the area of the base of the cone is going to be pi times the radius squared, which is 9 pi square meters. Again, do not round early. We're definitely not done with this thing. We're going to have to be subtracting some stuff afterward. Don't forget that. So the volume of this thing, remember the height is still 8 meters. That hasn't changed. The height is universal for both of those. So it's 1/3 area of base times height for the cone as well, only it's a different area of base. So 1/3 area of base times height. 1/3 of 9 pi is 3 pi, right? And 3 pi times 8 is 24 pi. So 24 pi cubic meters. That's probably around 75 or so, because 24 times 3 is 72, so a little more, probably around 75. So when we do 216 minus 75-ish, I'm guessing it's going to be around 140 is the answer. I don't know. I haven't done this problem. So we'll check it out. The volume of the total thing, we're going to subtract V2 from V1. So volume of total is going to equal 216 minus 24 pi. That would be an exact answer, by the way. We couldn't combine these things. That would be an exact answer in terms of cubic meters, but we will go ahead and approximate that for you. Let's check it out. Let's go to the calculator and let's look at 216. I'm projecting around 140. 216 minus 24 pi. There we go, 140.6. Now, nearest hundredth, 140.60. The 1 doesn't kick the 0 up to a 1, but I do want to write that 0 because nearest hundredth means I want to be precise to 2 decimal places. So 140.60 cubic meters. And there is your last volume. So that does wrap this thing up, guys. Just as a quick recap, we are finding the volumes of these things by doing area of base times height, or 1/3 area of base times height, or 4/3 pi r cubed based on a sphere. I have pointed to the fact that we've had some hemispheres, half of a sphere, in which case you take half of this, that'd be 2/3 pi r cubed. We didn't see this here, at least not in any composites or anything. We could see things, semi-cylinders. We could see some different things that pop up. Just divide your volume by 2, because that's how that works. The names of these shapes are based on the bases, unless they're circular in nature, in which they have specific names like cylinder, cone, and sphere. Otherwise, they're rectangular, or triangular, or hexagonal, or trapezoidal, or whatever they are. Take the area of the base, multiply it by the height, have your cubic units in the end, and organize your work. Definitely organize your work. I sure hope that helped. All right, that ought to do it for this one, guys. I did get this in good time. Let me know if you have any questions down below in the comment section, and of course, you could have downloaded this PDF in the description section as well. Thank you so much. Take care.